Geometry. Today we're going to use trigonometry to determine area of triangles. So let's try these three problems. Three triangles are presented below. Determine the areas for each triangle if possible. If it's not possible to find the area with each, with the provided information, describe what is needed to determine the area. I've moved this one to a new slide so we have enough space. Let's see, the area of any triangle is 1/2 base times height. Well, I see the base of this first triangle is 5, and the height is the altitude, or the distance from a vertex to an opposite base at a perpendicular angle. So I have 1/2 base times height. Well, 5 times 12 is 60. Divide by 2 is 30. Units squared. If we look at the second one here, again, 1/2 base times height. Base is 20 and the height is 8. 20 times 8 is 160. 1/2 of 160 is 80. Units squared. Cool, let's look at that last one. So you see it here. I have area equals 1/2 base times height. So I have the base at 15, but for this triangle we actually don't know the height. And given the picture, I don't have enough information to solve it. So let's figure out what's going on. The area of triangle GHI, let's talk about it. To figure out the area of a triangle, we really need to know the length of the altitude. Okay, the altitude always drops from a vertex to an opposite side at a perpendicular angle. So how do we do this? Well, I can't use Pythagorean Theorem because I don't know just this part of the angle or just this part of the angle to figure out this one. So I can't use Pythagorean Theorem. I can't use any of my sine, cosine, or tangent stuff because, well, we don't know any angles, do we? And we can't measure the angles. That's just not very accurate. We've sort of proven that in other lessons. So what we need to do is get a little creative. So if this whole base is 15, I can say that this little piece right here, I'm just going to name it x, just to give myself a variable to work with. And then this whole area here is going to be 15 minus x. So 15 minus x is this part, and x is this part. We now at least have something to mess around with as far as Pythagorean Theorem goes. So let's see, and we're going to label this, our altitude, as h. So Pythagorean Theorem, use the left triangle or the right triangle. I would recommend the left because we just have an x to work with versus a 15 minus x, because remember we have to square some stuff. So we have leg squared plus h squared equals 49, which is 7 squared, right? And then on the right side, we have leg, which is 15 minus x squared plus h squared equals 144, which is 12 squared. Okay? So since we can set these both equal to h, or set, yeah, so I'm going to move the x squared to the other side of the equal sign, 49 minus x squared, and then I have this one over here, h squared equals 144 minus 15 minus x squared. These are both equal to h, so I'm going to go ahead and set them equal to each other. Okay, substitution. 49 minus x squared equals 144. And I'm actually going to go ahead and FOIL this. Remember FOIL, first, outer, inner, last. So I have 15 times 15, which is 225. This is what I'm doing. 15 minus x times 15 minus x. Let's erase everything else here because it's all getting in the way. Excuse the delay. So I'm foiling first, outer, inner, last. So first is 225, outer is minus 15x, inner is minus 15x, and last is plus x squared. So let's go ahead and substitute this long thing with a little bit of simplification in for that binomial. Ooh, I found a mistake. You guys don't tell me about my mistakes anymore. Either you're not paying attention or I haven't given you candy in a while. I don't know. Alright, let's substitute that in. So I have minus 225. Remember, I need to distribute this through. This gives me negative 30x, but that gives me plus 30x. Oh, I found another mistake. Goodness. Minus x squared. So I distributed this negative through this polynomial. Alright, I can simplify a little bit more. I have a negative x squared on one side, negative x squared on the other. They cancel out. I'm going to go ahead and move all the whole numbers over here. So minus 144 plus 225 equals blah, 130. 130 equals 30x. Divide both sides by 30, and I think we'll have x. 130 divided by 30, 4.3. So x equals 4.3. Not done yet, but it's alright. What? Okay, I'm going to take the important information to a new slide. Okay, right now we solved for x. I lost my pen. X equals 4.3. Alright, so now let's find h. I'm going for the easy equation. I had two equations on the previous page. One of them said h squared equals 49 minus x squared, or plus 49, oh wait, nope. Let's see, I'm starting over. I need my original equation. Pythagorean Theorem, it's very important. So I have leg squared plus leg squared equals 49. There we go. So h squared equals 49 minus x squared. So 4.3 squared, 49 minus that. So I tried to keep everything in my calculator so I didn't lose anything with rounding. So I have h squared equals 30.2. Still in my calculator though. I haven't cleared my screen. I'm going to go ahead and take the square root of that number, and I got h equals 5.5. And we're not done. Long problem, I know. So now we need area. Area equals 1/2 base times height. Now you have to remember, the base is the whole thing. So we have 1/2, 15 times 5.5. That gives us 41.25 units squared. Awesome. That was a lot of work, but we got it. Good job. All right, let's look at the triangle, which is very similar to the triangle we looked at in example 1. If we want to write an equation for area, we're good. 1/2 base times height, which gives us 1/2. Base is A, height is H. So here's our equation for area of this particular problem. I'm going to rewrite this over here. We're going to mess with this a little bit to see if we can develop something that's easier to use than all the work we just went through. Alright, so the first thing I'm going to do is multiply this statement by a fancy way to say 1. What happens if I take B and divide by B? I get 1. Awesome. That would give me, I'm just trying to figure out the best way to present this. There we go. I'm going to do that little multiplication and mess with it. So I have A, H, B over B. I don't like how that looks, so I'm going to mess with it again. That gives me area equals 1/2 AB H over B. Ooh, what's H over B? Interesting. Let's keep this in mind and start thinking about what does that look like, right? Alright, I'm going to look at angle C for a little bit, and we're going to name this, hey, guess what? Theta! Yep. So our vertex C is now theta. What do you guys notice about H over B? What does it look like? Think about our trigonometry, which is what we've been looking at for a long time. Well, sine of theta equals H over B, doesn't it? That's pretty cool. So we can actually rewrite this area equation 1/2 AB sine theta. Crazy, I know. You might want to highlight that or write it down somewhere and circle it and star it. So if the area can be expressed as 1/2 AB sine theta, which part of the expression represents the height? The height is actually B sine theta, because if we look at this and we multiply both sides by B, those cancel out, and I'm left with B sine theta equals height. Aren't I? That's so cool. So B sine theta represents our height. Well, I thought that was total fun. All right, let's try to use it. Example 2. A farmer is planning how to divide his land for planting next year's crops. A triangular plot of land is left with two known side lengths measuring 500 meters and 1700 meters. What could the farmer do next in order to find the area of the plot? Well, I need a picture because I like pictures. And I'm in blue, sorry. I'll make this one a little longer. Oh, goodness. I have been terrible at drawing triangles since I started this lesson. There we go. It's not drawn to scale. I have 500 and 1700. Do we know anything else? Triangular plot, two known side lengths. For the area, we need to know the height. So what could he do in order to find the area of the plot? Well, he could either measure the third side. So his first option is measure the third side and apply the Pythagorean theorem. To find h, and then calculate the area. Or he can measure the angle. That didn't spell right. Measure the included angle between the known sides. It needs to be between the known sides because if we're going to use sine, cosine, or tangent, we have to know what the measurements are. Okay, so suppose the included angle in between the known sides is 30 degrees. All right, what is the area of the plot of land? So we just said that area equals 1/2 AB sine theta. Well, I've got A and B and theta. So 1/2, 1700 times 500 times sine of 30. Okay, get out your handy dandy calculator, start typing. 1/2 times 1700 times 500 times sine 30. Cool. That gives me 212,500 square meters. That was sort of fun. So much easier than the last one we did, isn't it? All right, exercise 1. A real estate developer and her surveyor are searching for their next piece of land to build on. They each examine a plot of land in the shape of triangle ABC. The real estate developer measures the length of AB and AC and finds them to be approximately 4,000 feet, and the included angle has a measure of approximately 50 degrees. So we're talking about about 50 degrees here, and 4,000 feet, and 4,000 feet. The surveyor measures the length of, oh, I should label the sides, sorry, A, B, C. The surveyor measures the, measures the length of AC and BC and finds the lengths to be approximately 4,000 feet and 3,400 feet, respectively, and measures the angle between the two sides to be approximately 65 degrees. So let's draw that picture. So I have, we said A, B, and BC 3,400 with approximately 65 degrees. Let's see, 65 plus 65 is 130, plus 50 is 180. We got it. Just making sure. So there's my funky picture. That's crazy, isn't it? All right, so I've got the diagram that models the situation, labeling all lengths and angle measures. It's a little messy. I think I'll redraw it the next slide a little bit bigger. So let's move on. The real estate developer and surveyor each calculate the area of the plot of land and both find roughly the same area. Show how each person calculated the area, round to the nearest 100. Redraw the diagram with only the relevant labels for both the real estate agent and the surveyor. So I'm going to draw two pictures. I'll be right back. Alright, check out two different ways that we could look at this drawing to solve it. And we're using our fancy new area formula. Area equals 1/2 AB sine theta. Okay, so let's see. We always look at the included angle, and we only need, so here, if I look at this drawing here, there's my included angle, so I only need these measurements, which is why I didn't put that measurement on the drawing, because it's not necessary. I didn't want to confuse things. So we look at our included angle and the sides that are adjacent to that angle, and that's how we calculate our area. So I have 1/2. It doesn't matter which order you write the 3,400 and the 4,000 in. It's multiplication, so I can write them either way. 3,400, 4,000, sine 65. Need a calculator. 0.5. So I have 1/2 times 3,400 times 4,000 times sine 65. That gives me an area of 6,162,893. 6 million, and I'm in feet squared. Okay, let's look at this one. If you look, I included only the sides and the included angle, and I can use the same equation. So to find h, I've got the two adjacent sides with the included angle. So area equals 1/2 4,000 times 4,000 times sine 50 degrees. Type it out. Times sine 50. I have an area of 616,8355 square feet. It looks like we're off by just a little bit. Not too much. Okay, let's move on. Push pause and make sure you understand this, or start, and we can talk about it tomorrow. What could possibly explain the difference between the real estate agents and the surveyor's calculated areas? When we approximate measurements, that could be it. If I go back and look at the description of the problem, they each examine a plot. The real estate measures and finds them to be approximately 4,000 feet. Their surveyor measures and finds them to be approximately 4,000 and 3,400 feet. So if you have approximate measurements, you're going to have some error. So you would need exact measurements to get more of an exact answer. Cool. That's the last slide. Awesome. That was sort of fun. I'm glad we have a new way to calculate area now. Let's do the problem set tomorrow. Nice work today.